If we put points on a circle and we count how many regions we get this very familiar pattern. Can you guess what will happen if we added another point? Exactly right, we're going to get 16. In fact, pause the video and check that that's exactly the number of regions. But check very carefully, because if you think the next number is 32, which would be predictable, you would be wrong. It's actually 31. Believe it or not, that very familiar pattern of just taking powers of 2 does not persist in this particular example. I'm teaching discrete math this year, and I'm going to show this to my students the very first day as a cool example of something where it really looks like a pattern, but then you see things change around a little bit. If you want to know the actual formula, it's something like this, and we don't have time to go through all the details, but I can at least show you an idea of how we might build this recursively or inductively. The idea is to think about what happens when we add another point. If I add a new point here, these 4 regions should now go to 8 regions. Let's see why that happens. Well, when I connect the dots, notice that I'm going to get 3 new red regions right off the bat, because everything coming from that point is going to split that red region into one more region. But then when I keep going, as soon as I cross this line, I go from red into that white region, and I'm going to get 1 extra region for that. And so why did I go from 4 to 8? Because I added 4 more regions. Let's see what happens as we go from this picture to the next one. If I add 1 more point, I'm going to have to draw in 5 different lines, and those lines are all going to add a new red region at the bottom. Let's write that like this: 1, 2, 3, 4, 5. But then let's think about what additional regions we're going to get. One way is just to count all the lines that we cross. This first one crosses 3 different lines. The next one is going to cross 1, 2, 3, 4, and the last one crosses 1, 2, 3. We could try and look for some sort of pattern, but for now, let's just write it down. So 3, and then 4, and then 3. Now, I want to point out that if you're trying to figure out how many lines would these green lines cross, the answer is to look at what's to the left and what's to the right. Let me show you a picture to break that down. Imagine we had a much bigger picture and I drew in this line here, and I wanted to know how many lines it might cross. Now, it's definitely not going to cross any line like this, or even like this or this. It's only going to cross the lines that start on the left, and look, there are 4 options there, and it has to end with one of the points on the right. So altogether, I've got 4 choices over there and 8 choices over there. If I count how many lines this green line is going to cross, it's going to be exactly 8 times 4, or 32. Now, as I move this green line, say from there over to here, that's going to change, right? Now there's only 3 things on the left, but there's going to be 9 on the right. So instead of 32, I'm going to get 3 times 9. If I put all those numbers together, I would get some sort of sum like this, and that would tell me how many new regions I would get. And so that 3 was actually 1 times 3, because there was 1 point to the left and 3 points to the right. And that 4 was actually 2 times 2, because that middle line had 2 points to the left of it and 2 points to the right. And so that's how the recursion would go. If you write down what happens in general, you get some formulas like this, which we'll also learn in our discrete math class how to solve. And then at the very end, you get that formula I showed you earlier. I think this is super cool.